Welcome to beginning of this year's Science Cafe. Tonight marks the 144th, so we expect by the end of this year to have reached 150 Science Cafes. So thank you for coming. I'm Paul Adams. I'm Dean of College of Education, oversee some of the work of SMEI, and we welcome you to this public presentation where we have some of our faculty, or staff, or community members that want to share something that's of interest in science for all of you. So we appreciate you being here, and if you're avid football fans, well, that's okay. The game will go a while, so you'll get through that. But we thank you for coming out tonight and afterwards for some more. So for tonight, to kick us off this year, we are a month later than usual, but that's fine. And you can see the Biochemistry Lust Attraction Companionship, which maybe we should have saved you for February, but we're going to have it come tonight.
Next time.
So let's all welcome Dr. James Balthazar.
Thank you. All right. Is this live or is this live? Okay.
Yeah, that one.
Both? I don't need this one.
For the recording.
Oh, okay.
So that one should be.
I can do that.
The one over here.
Okay, we can do that. We'll make sure it's working. Okay, well, thank you for having me. It was great to get asked. This is my second Science Cafe. And I had given this talk to the chemistry students, and I'll be honest with you, I hadn't opened it since I gave it. And thankfully, Maggie caught me and said, change the date. But I wanted to talk a little bit about the biochemistry behind lust, attraction, and companionship. You know, a lot of things drive love. Scientists in fields from anthropology to neuroscience have been asking the same question, probably albeit less eloquently, for decades. But it turns out that the science of love is a lot more simpler and a lot more complex than what we actually might think. So, spoiler alert, if you Google the biochemistry of love, you may get some answers that run the gambit of decency and scientific accuracy. And a lot of times love is basically sensationalized, and with most science, you know, we don't know a lot of firm conclusions, but we're trying to get a little bit of the piece of the puzzle here. But throughout this talk, I want to talk a little bit some of the chemicals that are involved in love, and a very similar pathway is that of music. So music tends to hit those same dopaminergic receptors. So specifically, I've spiced in a few clips along the way, maybe to get your biochemical pathways grooving. And every time you see a quotation, that's a song title. I don't own any of the rights to the title or to the songs. I pulled them off of YouTube. So please don't turn me in and get us canceled here. But we'll get you in the right mindset and move forward here. Let's see if it works. They turned me down. Maybe. There we go. Oh, it's not working. It's supposed to play music with us. Okay, well, maybe it won't work as like we thought. It sounds like every time the microphone goes off, it's going to shut off the music. But I want to talk a little bit about our topics, and these are song titles. So Love on the Brain, Rihanna, Let's Get It On, Marvin Gaye, Lust, Can't Fight This Feeling Anymore, oh man, we're head over heels in traction. And this is where we're going to specifically talk about each of the chemicals that are involved with each of these feelings. So think about the last time you found somebody attractive. My wife couldn't make it here tonight, but when I saw her, I probably stammered a little bit. My hands were a little sweaty. I probably said something pretty asinine and tripped up spectacularly trying to saunter in. But chances are, your heart's pounding. You are really just going haywire. Your body's going haywire. And most of the time, according to a team of scientists at Rutgers, Dr. Helen Fisher, I believe, is who did the research, romantic love can basically be broken down into three different categories. There's lust, attraction, and attachment. And each characterized by its own set of hormones. There is a little bit of overlap that we'll talk about, but each of these are stemming from the brain. So every time you think love comes from the heart, You're absolutely wrong. It comes from your brain. It may feel like your heart's beating out of your chest, but that's just norepinephrine and dopamine and testosterone just running the gambit, really hitting your limbic system there. So, with that being said, we're going to jump into our first set here. So love on the brain. Let's see if it works. I'll try not to talk so we can get a little bit of music. Okay, so love on the brain. You got some Rihanna there. So now, I have said that most of this is coming from the brain, but we do have a little bit of sex hormones that are not going to come from the brain. That's ovaries and the testes. Those are going to secrete our testosterone or our estrogen, and that's really what's going to drive our sexual desire. But dopamine, oxytocin, vasopressin, all of these are made in the hypothalamus, and that's a region of the brain that really controls a lot of the vital functions, as well as emotion. So that's probably why you get a little bit goofy when you fall in love. And a lot of those regions of the brain happen in that prefrontal cortex. And that's really why your rational thought tends to go away once you fall in love with someone, because it turns out you can't keep both things running at the same time. Either you can be in love or you can be rational. And I always tease my wife, the first date we went on, she jumped out of my boat on the lake. She can't swim. So she had to have been head over heels in love with me because she can't swim. And I like to remind her that, and she says, well, it must have backfired because I'm still here. So apparently. Lust is our next one. I love it. Marvin Gaye. So I spoke and it shut her down. But when we get to lust, lust is driven by your desire for sexual attraction and sexual gratification more so. And the evolutionary basis for this really just stems from our need to reproduce. And this is a need that's shared among all living things. So right now I have a 14-year-old at my house that absolutely thinks I'm ridiculous and hates me. And we talked about this at dinner. And that's a biological drive. There's a reason why he hates me, is because his body and his hormones are telling him, you should get out of here and reproduce somewhere else. We're preventing inbreeding, right? So it's totally normal that your children hate you. It's because they are trying to go through this phase of distancing themselves for a little bit of genetic diversity. But I tell you what, about 24, mom and dad start being cool again. They start making sense again. And a lot of this is driven by estrogen and testosterone. So through reproduction, this is where we're passing on our genes and we're perpetuating this. This is totally coming from testosterone and estrogen. They're really far swamping. And while these chemicals are often stereotyped as male or female only, really they play a role in both women and men. So sorry guys, if you think you're jacked up on testosterone, estrogen's running in the background too, keeping you there leveled out. And these are things that effects are usually less pronounced in females. So estrogen is that drive for that really reproduction. So that may say why men are really keyed into it, or maybe that's just what women say, I don't know, that we're a little bit more sexually motivated, but during the times of ovulation, those estrogen levels are going to be high, and also testosterone levels. Biochemistry, we really look at why these occur, and it has to do with a binding pocket. And enzymatically, when these molecules come in, they're very, very similar. Unfortunately, we have an organic chemist in here that could really call me to the carpet. But if you looked at the two structures, chemically, there's not a lot of difference there. Yeah, there's a methyl group that's thrown in there, and there's a carbonyl instead of an alcohol group, but largely, they're very much the same. Now, if we look at what modulates these changes in these sex hormones, really there's very specific receptors that bind. So a layperson may look at those molecules and say, hey, those are very similar. And they are very similar, but they bind very, very differently and give different responses as we go through this. So it's called an induced fit, and this induced fit is very, very close. And without this induced fit, we don't get to move forward, and we don't get to get this let's get it on mentality. So this is very much a tertiary structure in proteins that are going to be played into, which leads to a quaternary interaction. Not to get a little bit overcomplicated, but if I was a three-dimensional structure and you're a three-dimensional structure and we interact with each other, we're having a quaternary interaction. And that's what these hormones are doing. They are interacting quaternary, sending a different signal cascade. So lust is just what it is. There's a reason why there's a heart over the genital region, because that's really what's driving this thing. So then we move into attraction. And attraction, it seems to be a little bit more distinct. It's something that certainly you can lust for someone that you're attracted to, and vice versa. One can happen without the other, though. Attraction usually involves some brain pathways that control the reward center. So attraction kind of fits a little bit different bill. This is dopamine. When you get something that is just phenomenal, that you really love, maybe it's Chiefs football. Maybe that gives you your dopamine dump. Maybe it's chocolate. Maybe it is your actual spouse. That's what we're hoping for here, right? But dopamine, produced in the hypothalamus, it's very well publicized player in the reward center. And this is released when something feels good to us. So no matter what you do, if there's something that you really, really enjoy, you can say that this is that response that you're going to get. For attraction, obviously, when you spend time with someone, you hopefully are going to get a dopamine dump. You're not going to be like my grandparents that yelled at each other across the room halfway through. I swear that was love, but that was probably more norepinephrine than anything. Norepinephrine is the other side of that. That's the thing that keeps us bound together. It's that fight or flight response. So when you are running from a bear and you get that big dump of norepinephrine that says, hey, we got to get away from this bear. That's the same interaction that happens when you fall in love with someone. So your body is literally saying, I like you, but I should maybe run away. So it's the same pathway that's going on as we go through here. So you can actually, these chemicals can make you giddy, they can make you energetic, they can make you euphoric, they can lead to a decreased appetite. Man, I love her so much, I just can't eat today. That's how I lost weight. I just love my wife. I did it surgically. Cut through it that way. But what you can do is you can throw somebody in an MRI scanner and you can see these pleasure centers really light up when they get something they want. They did a test and they brought in a box of kittens, and when someone that really loved kittens, their dopamine receptors and those pleasure centers in their brains just lit up. And the same thing happens when we're in love. And this happens in the ventral tegmental area of the caudulate nucleus. If you want to go into the region of the brain that it happens in the hypothalamus. And what it does is these neurons are going to fire like crazy. And they can also do a test, and they can put you in the same scanner, and they can show you pictures of people. And they can see if you're really, truly in love, if that same cascade pops up. So maybe you're laying in this tube and they show a picture of 1985 Carmen Electra really did it for me, but maybe it's a picture of my wife, maybe it's Carmen Electra, and now we look through there and we see really, truly, you can't fight the scanner. The scanner's going to know. The other thing that attraction leads to is a reduction in serotonin. So serotonin is another hormone that's known, it's also involved in appetite and mood. People who suffer from OCD, obsessive compulsive disorder, also have very low levels of serotonin. And this leads scientists to speculate that what leads to the underlying this overpowering infatuation when we fall in love with someone is what really characterizes the 4 stages of love. And if you were to look at the 4 main dopamine pathways, there's, I don't know, Dr. FHSU, do you remember? I don't remember. It was mesolimbic, mesocortical, I got my notes here. Let's see, mesocortical, nigrostriatal, and tubular and fibular. And the mesolimbic one is the one that's really tied to reward and to the motivation center. And this is really what's going to be upregulated. It's the same response that we get when we have a baby as well, right? We want to fall in love with that baby. Moms are going to get that big dopamine dump. Maybe not dads right out of the gate, but everything is so complex and tied together. It's very, very complex. This dopamine response, when we have this attraction holding this very little baby, it not only for a mother, it stimulates prostaglandins, which actually stimulate breast waking it up so they can produce milk, and it actually turns on the pituitary gland. But it hits 300 or 400 different regulators in the pathway. So when we fall in love, and I say it's complicated, it is very, very complicated. Our last direction is, once we are through attachment, is finally we are in love. And these are what are going to regulate our love. So I always tell my wife, hey baby, you like a little oxytocin in your life? Come over here. It doesn't really work for her. It's never worked for her. But we're going to see if it works for you. So there's a downside to this, especially if you're in this attachment phase and maybe you have oxytocin that's dominating. Sadly, maybe it's vasopressin and you've been friend zoned. Friend zone is a real place, right? While lust and attraction are pretty much exclusive to romance, oxytocin is really one of those regulating hormones. Another term for oxytocin is the cuddle hormone. So usually when you fall in love with somebody, you tend to want to be around that person. You tend to want to cuddle with them. And for that reason, dopamine and oxytocin are really the things that are most widely produced in super large quantities. When we go through actual biochemical love, the things that are really kicking off are oxytocin and dopamine. And those are the 2 chemicals that are really driving that we are going to maybe want to copulate. Eventually it's going to lead to breastfeeding. It's going to lead to making more children and childbirth. These things are very regulated, not only in love, but they actually help a pregnant female as they go through the same stages when they're getting ready for childbirth. So it's an assortment of activities. I can't say that all of them are probably enjoyable. Mom, how was childbirth? I don't know. No, we won't go that way. But it's pretty clear that all of these chemical reactions are what are leading to our attachment, our lust, and our desire. Now, there is a negative side of this. If you could hear it, if it was a little bit louder, we would hear some love stinks. And everything I've kind of talked about, hormones are painting this beautiful rosy picture of, oh my gosh, I'm so in love with this person. But it's the same hormones in a different level that regulates the flip side of that same coin. So maybe you have fallen out of love with someone.Maybe you are in the friend zone. It's still going to be the same chemical pathways, just in a different level. So the way biochemistry works is a lot of this is based on transcriptional levels. The more we upregulate or downregulate something, the more response we get. And maybe a flood of dopamine makes you love someone, but starving from dopamine makes you hate someone, right? So it's the same molecule, it's the same receptor as we're moving forward. And a lot of times, the same hormones that make us feel good really are going to make us jealous, erratic, have some crazy behaviors. Ultimately, they're the same behaviors that lead to abuse of maybe alcohol, maybe binge eating, maybe adultery, the same things that make you want to have a positive relationship are going to cause you to have a negative relationship as well. The hormone responsible for the downside of love is still dopamine. So dopamine is, yay, we're in love, but dopamine is still the same molecule that says that we're not happy. So it controls the good and the bad. We get surges of dopamine. And the same regions that light up when we're feeling attraction are the same regions that light up when we are having maybe an addiction to drugs. So maybe you're in love with someone, or maybe you just really like whatever drug that they're putting in your meal, right? It could be the exact same thing. They're the same signaling. Now, the difference is the time that dopamine stays spiked. Typically, the longer the dopaminergic response, the better the outcome. So if you're really, really in love with someone, you're riding high much higher, right? It's the honeymoon phase. Some of us last a little bit longer than others, and then it's not as strong as it could be. So an addict that undergoes withdrawal is no different biochemically as someone that's been friend zoned. It's the same type of thing. So it's not unlike a love-struck person that's craving company for someone that they can't see, or it's somewhat similar to that of oxytocin. Oxytocin is another good thing that can go bad. Recent studies on party drugs like MDMA and GABA, GHB, they're showing that oxytocin is still the main hormone that causes the high. It's the same high that we get with love. So your brain is really hardwired for, did I get enough to make me happy, or am I just not getting enough and I'm going to be unhappy? So even though oxytocin's role is to form this bonding, you can supersede it with certain levels of dopamine. Now, if I had to say the thing that's driving the most important thing for our long-term relationships, it's going to be oxytocin. When you get up in the morning and your wife, my wife never has this, but when my wife would, if she would have morning breath, there's no amount of dopamine that's going to make me fall in love with that again, right? But the oxytocin is going to carry me through until we get home with supper and she's brushed her teeth and man, she looks amazing, right? Biochemically, everything works like there's gas pedals and brake pedals. So a little bit of dopamine may be like a gas pedal, a lot of dopamine may be like a brake. It's all transcriptionally regulated. But it's so complicated because we don't know how much of each hormone is going to be produced. As we produce more and more of one hormone, it tends to tip the scales in one favor, but not always. You can still get those same things. Now, attachment, lust, those are all great things. They don't tend to always bode well for monogamy. They tend to drive us to want to keep looking. You keep chasing that white rabbit, so to speak. So oxytocin, it's also been tagged with us chasing things outside of maybe what we have at home already. So it can be a double-edged sword. So if you're chasing that dopamine high with your spouse, just know a little bit too much dopamine can cause us to essentially run away from them. Okay, and finally, what would be love without embarrassment? So you know that tingly little feeling when you like someone, that's common sense leaving your body. That can't be more true than anything. What would love be without embarrassment? Sexual arousal, not necessarily just attraction. It appears to turn off regions in our brain that promote critical thinking. Unfortunately, self-awareness, rational behavior are all in that same prefrontal cortex. So every time you get that big dump of dopamine, you think this is the one, I'm falling in love. Maybe you're in college, maybe you're finding your first love, you're leaving McMinus Hall after you had your meal planned together, and oh, this is the lady for me for the rest of my life. It could be that your body is playing a trick on you, and that your biochemical pathways have in short, make you dumb. Have you ever done something in love that you regretted later? My wife jumped out of a boat. Now she's stuck with me, right? What about, Shakespeare, right? Romeo and Juliet, they went down a bad path. It's a little bit late for them. There's no formula for love. I mean, really, there's no biochemical pathway that's going to tell you what's going to happen. It's a work in progress. There's a lot of things that's left unanswered. And the hormone side of the equation is so complicated that it is something that we don't necessarily understand fully. There are not really drug analogs for dopamine. It would be bad if we did drug analogs for dopamine. Now, we do things like epinephrine. Maybe you need to run from that bear, or if you're working on the ambulance, you need to drop an amp and epi on somebody so you can bring them back. But if we were self-medicating with dopamine and oxytocin, we would have such a problem. And in the end, everyone is capable of defining love for themselves. It's really all about hormones. You can't fight your biology, and you just can't have chemistry without these chemicals. So I would be happy to answer any questions. I did promise I would try to keep everyone on task so we can get to watch the Chiefs game, but I'm happy to answer any questions. Thank you.